All right, guys, in this note set, we're going to talk about the periodic table and how it is organized. The periodic table pretty much arranges all the elements in a particular way. It has vertical groups, which are called vertical columns, which are called groups. Groups are numbered from 1 to 18. For the purpose of this class, sometimes we skip over the ones in the middle and we just say 1 to 8. So if you hear me say group 8, I'm talking about those in group 18. So same thing. 7, 17, 6, 16. So yeah, so don't be confused by that terminology. Valence electrons are electrons that are located on the outermost level. Each element in a group has the same number of valence electrons. So as long as you're in group 1, it doesn't matter how many shells you have, you will still only have one electron on your outer shell. The periodic table is also divided in periods, which are the rows going across, right? Each period starts with an atom with one electron in the outer energy level, and it ends with an atom that has a full energy, full shell. The periodic table has three main sections of elements with similar properties. Metals are those in green in this picture, the nonmetals in orange, and the metalloids are in purple. The metals, their properties include they are very good conductors of heat and electricity. They're usually solid at room temperature, except for mercury. They are reflective, so shiny looking, malleable, and ductile. They're located on the left side of the periodic table. And your alkali metals specifically are the first column of the periodic table here in orange, except for hydrogen there, which is a gas. They form +1 ions by losing the 1 valence electrons. The most reactive metals on the periodic table, they are the most reactive metals on the periodic table. And for example, sodium will explode when it's exposed to air. Sodium in its elemental form. Alkaline earth metals, those are your purple right here, right next to group 1, so group 2. They are the second group on the periodic table. They're also very reactive, but they're not as reactive as the alkali metals. They form +2 ions by losing the 2 valence electrons. Your transition elements, they usually exist uncombined. They are not as reactive as some of the other elements, so they're relatively stable. They usually form multiple positive ions. For example, you could have copper 1, 2, or 3, depending on what compound it is found in. Then we have our nonmetals, they are usually gases or brittle solids at room temperature, except for bromine, which is a liquid. They are not malleable, not ductile, right? They're not usually conductive. They don't usually conduct electricity. They're not usually reflective. They form negative ions by gaining valence electrons. Then we have our noble gases, which is in light blue. So group 0, group 8, group 18, right? There are helium, neon, argon, krypton, and xenon. So they're group 18 or 8. Sometimes I refer to them as group 8. They are the most stable of all the elements. They do not react with other elements under normal conditions. So they're very, very stable. They're the most stable. We have our halogens, kind of skipped over them. We have our halogens, they're group 7 or 17. They are not usually found in nature alone, but as salts combined with a metal. Some are called diatomic molecules because they exist in molecules of two atoms. So like fluorine is F2, chlorine gas would be Cl2. They readily gain one valence electron to form a -1 ion. They're very reactive, all right? They really want to be stable, so they will react. And they are the most reactive nonmetals. Diatomic molecules, some nonmetals exist, I just said that, exist in molecules of two atoms. So for example, oxygen is another one. Or metalloids, they are elements that have properties of both metals and nonmetals. They are group 3, 4, 5, 6, and 7. Some of them are in each of those groups, right? Or 13, 14, 15, 16, 17. So it goes diagonally, as you can see in that picture. The metalloids are boron, silicon. I'll pause here so you can write. All right, or you can pause if my pause is not long enough. I have to finish this in 15 minutes. I think I said that already. All right, so they have a combination of properties of both metals and nonmetals. They're in a zigzag pattern from the top, from boron to polonium. And anything touching two sides of the zigzag is a metalloid, except for aluminium. So periodic trends, guys. And again, I'm going to try to wrap this up in 15 minutes. So the periodic table, there are several trends within it. So repeating patterns. And this is going to be very helpful because it allows you to predict what might happen with something. All right, so there are three main trends. They are atomic mass, atomic radius, and reactivity. The atomic mass, as you go from left to right, the mass increases. As you go from top to bottom, the mass increases. All right? So left to right increase, top to bottom increase because you're gaining more things. You're gaining more parts of this. You're gaining more parts, more matter. This is the word I'm looking for. All right. As as you go from left to right, there's an increase of matter. Set. Protons and the number of protons and neutrons increase in both of those directions. All right. So this is not on your paper, but we'll skip this one, do it in class. So which has more mass? I want you guys to refer to the periodic table that I gave you. And if you don't remember where to find it, it is in reference table earlier in Unit 1, Module 1. All right, so there's a trend of atomic radius as well, the size. Atomic radius is the distance from the center of the nucleus to the outside of the electron cloud. It's measured in angstrom. All right, so pretty much the width of the atom. As you go from left to right, the radius decreases. All right, as you go from top to bottom, the radius increases. All right. So why does that happen? As you go from left to right, the nucleus, right, has a tighter pull on the atom. Right. So as you go from left to right, the nucleus is pretty much getting stronger and stronger, and it's able to pull the valence electrons closer and closer. All right. Top to bottom, there's more energy levels being added. right? And so obviously you're getting wider and wider. So we'll do these in class. Oh, make sure you have them done for class. All right, the reactivity trend, it tells us how reactive elements are or how strongly they will interact with other elements. As you go from left to right, reactivity of metals decrease, right? Then the reactivity of nonmetals increase, but it stops at the halogens because remember what we said about the noble gases? They're noble, they're not into this mess of reactivity, okay? All right. As you go from top to bottom, reactivity increases on the left and decreases on the right. Metals at the bottom lose electrons, and nonmetals at the top gain electrons. Therefore, those corners are the most reactive. The most reactive metal and nonmetal start with F, and I want you to tell me where they are in class. Okay? All right. Bohr models, as we did in our little research, we discovered that Bohr model is the best way to represent an atom. Well, one of the ways to represent an atom. Um, so one way to see the trend of valence electrons is to draw a Bohr model. So remember, Bohr placed electrons in specific orbits or energy levels. Whoever did Bohr. Um, the first energy level only has 2 electrons, the second has 8, and the third has 18. And we're not going to get past the third, at least not in this class. All right, so let's draw the Bohr model for some of the elements in group 1. All right, so that's hydrogen. I want you guys to put some dots or X's on the diagrams that you have. All right, so make sure you have that added in. All right, and what do you notice? Hint, hint, it has something to do with the group that it's in. Also, remember that you need to have 2 on the first, 8 on the second, and no more than 18 on the third. Okay? Valence electrons are very important in our next unit because they help us determine how something reacts. All right, that is it. I will see you guys in class. That's 13 minutes.